we have my favorite student, good old Anne. Number 1, an airplane turns a complete horizontal circle in 2 minutes. Nice try, Duick. We don't do physics with 2 minutes. 120 seconds. If the plane's speed is 170 meters per second, what's the radius of the circle? Well, they gave me speed. I said, I think I'm going to use circular speed is 2 pi r over the period. I lifted that right from my formula sheet. It's really distance over time in disguise. They want me to get the r by itself, so I said, okay, r I guess is going to be v times t divided by 2 pi. So I said it's going to be v 170 times t 120 divided by 2 pi. 170 divided by 100, or divided by Mr. Dewick, times 120 divided by, in brackets, 2 pi. And I got 3,200, and if I go to 3 sig figs, 3,250. And at first I started to get a bit nervous because that's like 3.25 kilometers. But then I said, oh, wait a minute. It's taking 2 full minutes to go around the circle, 120 seconds. And this plane is moving pretty fast, 170 meters per second. That's fast. You know what? Yeah, it's going to be a big circle. I'm okay with that. So then I got comfortable and relaxed. What's the centripetal acceleration of the plane? I got a few options. I could use v squared over r, or I could use 4 pi squared r over t squared. I said no matter what, I'm using my answer from A. So I wimped out and just picked the easiest, least typing one. I used v squared over r. 170 squared divided by, I wrote 3,250, but you know I'm using my answer button. And I got 8.89. Oh, that was dumb of me. Why did I not use my answer button? Let's try that again. 170 squared divided by, how would I have done that? That was strange. Answer button. I got 8.9. This would be a fairly comfortable turn because you'd feel a tiny bit lighter, but not much. You're basically pulling a G. Pretty comfy. Number 2, what centripetal force? Okay, when they ask for centripetal force, I'm not doing a free body diagram in the same way as when they ask for the net force, the what force, the net force, I can go straight to F equals ma. I can go straight to F equals mac. Which version of A am I going to use? Period. It's going to be m 4 pi squared r over t squared. It's going to be 12 times 4 times pi squared times 6 all over 0.2 squared. And I got, 71,100 newtons. And I started to get a little nervous at that, but then I looked at the numbers. What's the mass in this question, Taryn? Bowling ball. That's about a bowling ball. What's the radius? 6 meters is about from me to you, roughly. So we're spinning a bowling ball. How long is it taking to go around once? Which basically means 5 times a second I'm spinning a bowling ball on the end of a 6 meter long rope. Would that take a fair bit of force? Yes. Okay, then I'm okay with that. I was nervous at first, and I looked at the numbers and I went, actually, that seems about right to me. Okay? I don't know why this one is worth 3 marks. It should only be worth 2. But anyways, for the previous questions, I would probably go half mark, half mark, half mark, half mark, 1 mark, half mark, half mark. Here for 3 marks, I guess I would go probably something like this. 1 mark if I saw that, 1 mark for the numbers, 1 mark for the answer. A belt passes over a wheel of radius 25 centimeters. Nice try, Duick. If a point on the belt has a speed, what's the centripetal acceleration? Okay, I guess they just want me to find AC. Well, my first thought would be v squared over r. Yeah, that works. 5 squared all over 0.25. I can probably do that in my head. Is it 100? Meters per second squared. Ooh, now let's look at an application. A Ferris wheel has a radius of 9 meters. It takes the wheel 25 seconds to go around once. Person who weighs 60, really I should have said who has a mass because weight is mg. I'll fix that. Who has a mass of 65 kilograms is sitting on the Ferris wheel bench. What's the force the bench exerts at the top of the Ferris wheel? This is asking me to find the normal force. I'm going to do a sketch, kind of a free body diagram here. So here's the top of the Ferris wheel. Here's the person. What are the forces acting on them? Get the obvious one. Definitely gravity down. And normal force up. Why did I draw normal force smaller? What path are we tracing out? Circle. Where's the bigger force going to be pointing? Toward the center. So I said, I got it. My equation is going to be mg minus fn equals m. Oh, they gave me period 4 pi squared r over t squared. Zach, what am I trying to find? How would I get the normal force by itself? Yeah, swappy dance, I think. Sorry, add the what? I don't think I'm going to add the mg over. What's right in front of the normal force I don't like? I'm doing swappy dance, my friend. I'm going to plus that there, and I'm going to minus that there. The mg is going to stay where it was, kathunk. But then I'm going to have minus m 4 pi squared r over t squared. And if you don't mind, I'm going to put the normal force equals on that side because that's where I like it. And now it's time to plug in the numbers. It's going to be m 65. G. Mr. Duick, there's an m in everything. Doesn't the m cancel? Does the m cancel? No. No, there's not an m in normal force. And in fact, when you're finding normal force, that's your apparent weight. The m won't cancel. That's why as you get heavier, you can age out of some rides. Rides that you liked when you were a kid, you might not be able to handle as easy when you were grown up. R 9 all over 25 squared. It's going to be 65 times 9.8 minus 65 times 4 times pi squared times 9 divided by 25 squared. Did you all get almost exactly 600? Three marks if you got that right. Otherwise, I would probably go something like this. Oh, I would probably go half mark for that. Half mark if I saw that. And then, oh, I don't know, 1 mark for the numbers and 1 mark for the answer, something like that. What's the force the bench exerts at the bottom? I'll do a quick sketch. There's the bottom. What are the forces acting on it? Get the obvious one. I have gravity and normal force. Why did I draw the normal force bigger? What path are we tracing out? A circle. Where is the bigger force pointing? Toward the center. So here it's going to be normal force minus mg equals m 4 pi squared r over t squared. Zach, maybe this is the one you were looking at. How would I get the normal force by itself this time? Add the mg over. Mr. Dewick, you wrote mg plus m4 pi squared r over t squared. Could I have written them in the other way around? M4 pi squared r over t squared plus mg? You could have, but I was so lazy I couldn't help noticing that all the numbers are the same, and all I really need to do is change the plus sign to, or the minus sign to a plus sign, but otherwise it's exactly the same typing. I spotted that, so I set it up the same way. 674, I think. Here I'd probably go 1 mark, 1 mark, 1 mark. If you wrote the numbers, I'd give you some credit too, but I was lazy. I noticed it was all identical. We get off the Ferris wheel. Ferris wheel is kind of a tame ride. You're not going to get much change in your normal force. Let's go on a better ride. Let's go on a circular roller coaster. I will be giving you a circular roller coaster on your test, even though yesterday I told you that we never actually build them anymore. I probably didn't tell you. The very first circular loop was the Shoot the Chute at, I think it was at Coney Island. It wasn't a true roller coaster. It was just at the top of a big hill. It was a track that had a circular loop at the bottom. People climbed the stairs to sit on a little mining cart kind of dealio. And they actually had permanent ambulances and nurses stationed at the bottom. People regularly got nosebleeds, blacked out, had whiplash, and they loved it. This would have been in the 1890s, 1900s, and then they started to realize maybe this isn't the safest way to go, because this would be pulling way more than 6 Gs, because this would not have been bare minimum. You would have been making it with speed to spare, probably pulling 8, 9 Gs on this when you were at the bottom. Not a healthy ride. But now, we don't make them like this, but for the test, we'll pretend we do. How fast? Well, I think this is going to be a job for a free body diagram. What are the forces acting? I'm going to have gravity down. And I guess in a roller coaster, I have normal force pointing down as well. I'm not sure whether normal force is... Oh, you know what? Actually, I should have drawn normal force way bigger than mg because it says it's 4.5 times as big as mg, but I won't be that fussy. Here's what I do know. Who's winning? They both are. They both are. It's going to be mg plus normal force equals mv squared over r. I don't know the normal force. Wait a minute. How do I calculate a person's weight? mg, so 4.5 times their weight. You know what? I can write this as mg plus 4.5 mg. That equals mv squared over r. In fact, I can gather like terms. 1 mg plus 4.5 mgs. Why, that's 5.5 mgs. That equals mv squared over r. Not only that, I could have canceled out the m, either on the previous line or on this line. Everybody has to go the same speed in order to feel 4.5 times their weight, whether they're a little kid or a grown-up. Doesn't matter. And they want me to get the v by itself, and oh, hello, my old friend. It looks like I'm going to get v is equal to the square root of 5.5 GR. I probably did this right. Uh, 11. 5.5 times 9.8 times 11. That's way too... Oh, square root. Don't forget the square root, Mr. Doug. 24.3. If you're bored, or did I ask it on part? No. If you're bored, you could calculate the normal force down there. I deliberately didn't because it's hideous. I think it's around 11 or 12 Gs they're pulling down there. Because they're pulling 4.5, not 0 at the top. They're pulling 4.5 at the top. They're pulling a lot at the bottom. After the first loop, the riders hit a second loop. Assume they're still alive. At the top of the second loop, the rider is traveling at 16 meters per second and they feel a normal force of twice their weight. What's the radius of the second loop? So I think it's going to be a really, really similar free body diagram in that I still think we're going to have gravity down and normal force down. I still think both are winning. I think it's going to be winner plus winner equals m, you know what? V squared over r, because they gave me a speed. I don't know the normal force. Yeah, I do. Twice their weight. And you could cancel out the m's on this line if you wanted to, or you could say, you know what? That's 3 mg's equals mv squared over r, but regardless, the m cancels. They want me to find the r. Where is the r right now? On the... Yeah. No, wait, stuff moves diagonally. This is 1 fraction equals 1 fraction. So I'm going to get this. R is going to be v squared over 3g. V squared, 16, don't forget the squared, all over 3 times 9.8. The second loop has a radius of 8.71 meters. If you got that, 4 out of 4. Otherwise, I would probably go, let's see, 1, 2, 3, 4, 5 lines. I'd probably go 1 mark for that, 1 mark for that, 1 mark for that, half mark for that, and a half mark for the answer. And on the previous question worth 4 marks, I'd probably go 1 mark for that. I'd probably go 1 mark for that, 1 mark if I saw that, and 1 mark for the answer. Can you give yourself a score, please, out of 23? Any lawyering with me? Now is the time.